As the 2023 National Electrical Code nears adoption across the United States, there are rising concerns around the changes and additional requirements amongst manufacturers, specifiers, and contractors. While each edition brings changes that are driven with the motive of improvements around electrical safety for both people and property, it creates challenges in quickly understanding what's changed and how you need to apply this. I'm Kelly Sinovich, U.S. Specifier Channel Leader at Schneider Electric, and I'm excited to be here today with a group of industry experts. With me here today is Chad Kennedy, Director of Industry Standards at Schneider Electric, Kyle Krieger, Director of Codes and Standards at NECA, and Toby Mitchell, owner of Classic Electric. So we're going to start with Chad. Chad, can you tell us a little bit about your expertise as well as who decides the changes?
Thank you, Kelly. So Chad Kennedy with Schneider Electric. I've been in the industry over 30 years. I participate on 3 NEC-related committees, Code-Making Panels 13, 15, and the NEC Correlating Committee. The NEC is a published document every 3-year cycle, and the change process is open to anyone. Anyone can submit a public input via a simple online submission. Those public inputs are then distributed amongst the 18 technical committees or code-making panels, which act on those to create first revisions. The first revision is also a published document that anyone can place comments on, and public comments then are acting on by those committees in a second draft phase, and that's really how the NEC gets formulated into a new revision. When we think about the 2023 NEC, we had over 4,000 public inputs and nearly 2,000 public comments in this whole process. And in the end, we ended up with 1,800 plus code revisions between the 2020 NEC to the 2023.
But
so
we're
it's
not going to
significant.
talk about 1,800 changes today, right?
Not today. We're going to focus on 5 key changes related to electrical contractors.
So Toby and Kyle, let's talk about a little bit about your expertise, and then I want to hear your perspective on how these changes impact electrical contractors.
Yeah, thanks, Kelly. So Kyle Krieger, Director of Codes and Standards with NECA. Been in the electrical industry for about 26 years. Worked as an inspector to the position I'm in now currently with NECA, and represent NECA on Code Panel 3 and the Correlating Committee. And careful, because if you ask code people to talk about changes, they're going to talk about changes.
Yes.
So we will discuss all 1,800 if you really want to. But it's, regulations are important to the industry. They keep people and property safe. That's the whole purpose of the NEC. And electrical contractors, as long as, they're more than willing to comply with these regulations as long as they know what they are and up to date on the changes. So it's important for them to do so. Toby, what's your take on this?
Toby Mitchell, Classic Electric Consulting. I got over 20 years experience in the industry. As a contractor, we need to be on top of these code changes to avoid unnecessary costs during the building process. We also need to make sure that we're educated so that we can talk with AHJs or our customers for the reason why these regulations have been in place and stuff like that, and make us more subject matter experts versus just regular installers. And I'm glad to be talking about these top 5.
Great.
Well, thank you all for being here with us today. So let's move on to our first topic, which is all going to be around servicing and maintenance of equipment. Kyle, can you walk us through the changes that occurred in the 2023 NEC and why they were implemented?
Sure, I'd love to. So the 2023 edition brought us a new code section, 110.17, specifically addressing servicing and maintenance of equipment and putting a focus on why that's an important part of the installation. And the installation of the equipment is one thing, but maintaining it is another part of making sure that it's safe and reliable. The service and maintenance requirements that we see now in this section really put a focus on the individual performing the maintenance to ensure that they're qualified. So you can't just have individuals that aren't familiar with that equipment and whatnot performing the maintenance and whatnot with that equipment. There's also some specific things when replacing parts and components of specific electrical equipment that the NEC now recognizes and adds some additional requirements to. Specifically, anytime you're replacing components, you have to consult with the original equipment manufacturer to ensure that you're replacing the components correctly or with the identified products. The replacement parts have to be identified per code. In lieu of that, you could consult with an engineer that has experience in that equipment and those types of design replacement parts. And then it's got to be approved by the AHJ. So these changes are ones that, it's an important change, but the fear is it might go under the radar with AHJs and contractors alike. But we really got to make sure that everybody understands what these requirements are and how they're going to impact, the industry at large. Additionally, there's some challenges that come with how do you determine if somebody is qualified to do and perform that maintenance? There's no roadmap that specifically tells somebody how, to identify a qualified person versus somebody who's not. This could bleed over into the insurance industry and some of the other things that go around protecting property and people. So there's a lot going on here with this requirement. The safety is always the underlying theme of any time we have electrical installations. And I guess the last piece of this is ensuring that a qualified person doing the work is important from a safety aspect and a risk management standpoint, because a lot of incidents, arc flash incidents and shock incidents that occur fatal and otherwise are directly related to the maintenance industry. So there's a lot of important stuff going on.
Kyle, when we think about a qualified person, we tend to think about NOP 70E. And this little nuance in the code, bringing the importance of service and maintenance by a qualified person, kind of extends that thought, right, in 70E. From an original equipment manufacturer standpoint, that's the first place to start for these maintenance and service instructions. The manufacturer has the most knowledge about the in-depth requirements of the design, one of the critical factors that need to be serviced and maintained over the life of that product. So it's really important that we make sure that you introduce or use the manufacturer's instructions along with that. Now, what do you do if there are gaps in that information or there are, the manufacturer doesn't provide instructions? Well, we have NOP 70B that had been a long-standing guide or recommended practice. As I think all of you know, that it was elevated recently and rewritten to a standard for electrical equipment maintenance. So between the manufacturer's instructions and 70B, we now have a platform that really supports electrical equipment service and maintenance and going forward. So I think that as we understand the importance of having a qualified person from electrical safety, from performing service and maintenance, coupled with the instructions by the manufacturer. So Toby, what do you do though if the parts are not available?
Yeah, I mean, we run in that all the time, right? Manufacturers discontinue a line, but always best thing is to seek out the original manufacturer to see if what their recommendations are, what the replacement parts are for that type of equipment. It's also reason why you want to use a reputable manufacturer who has been around for a long time, is going to be around for a long time. So when you need to maintenance that equipment in the future. But what happens when you have a manufacturer that's not around anymore? There's a lot of manufacturers that aren't in business anymore. And like Kyle was saying, you can get an engineer who's qualified in that to help you design and come up with that system. And they'll be able to take responsibility for that design as well. But it's also good to get the AHJ involved so they know what's going on.
From a big picture standpoint, this really explains or shows the ties between 70, the NEC, 70B, and 70E, and how all of these fit together, and these links that the NEC has really put into place, right? I think that when we think about equipment, service, and maintenance, it really all starts with the NEC compliant installation. And the elevation of 70B along with the manufacturer's instructions really sort of set that stage. Also, when we think about 70B and the qualified person discussion about qualified persons from a safety perspective, but also from a service and maintenance perspective, there are allowances in 70B for using measurement data, sensors buried in the equipment that can provide equipment health, and that can set the sequence or the prescriptive of schedules for when service and maintenance has to happen. And so that adjustment really means that electrical workers sometimes will have to go into the equipment less. So overall, I think this important tie that the NEC is making between 70, 70E, and 70B is a good one.
Yeah, Chad, more than ever, the 2023 NEC really is solidifying that link, and installation requirements that really support maintenance and safety are becoming a real thing now in the 2023 more than ever.
Yeah, and as contractors, we've all worked on poorly installed stuff, and I think this is really good to have the NEC say you need to have a proper installation so in the future when you're service and maintaining that equipment, you're in a safe situation.
This is a great segue into our next topic. Continuing the discussion in terms of worker safety, I want to talk a little bit about the NEC changes regarding arc flash hazard on equipment. Chad, what are your thoughts here?
So the new section 110.16b included revisions that apply to arc flash hazard warning labels on feeder and service equipment for 1,000 amps or greater equipment. Toby, can you explain how this differentiates between what the general hazard requirement 110.16a?
Yeah, I think it's important to note that the general arc flash labeling that comes provided by the manufacturer, this is above and beyond this. This is more system specific for your installation. And again, this is showing that the original installation is extremely important and ties along with 70B and 70E. But as far as that label goes, Kyle, can you explain what that label needs?
Yeah, so 110.16a is really the general manufacturer installed label stating that there's an arc flash warrant or arc flash hazard present. The 110.16b requirement is that label that requires specific information. The label now required to have available fault current, the clearing time of the overcurrent device, nominal system voltage, and then the date that it was installed. And we first saw this in the 2020 for service equipment, and now that's expanding. The information on that label specifically relates to NFPA 70E, another example of supporting that safety standard through requirements. That information that is required allows the user, the technician, to be able to apply the table method in 70E to select the appropriate arc flash PPE and do the job safely when necessary.
Yeah, as we look at this requirement in total, you know, it expands beyond the service equipment to feeder equipment. So that's sort of one of the big changes we don't want to lose sight of here. And this alignment, you know, really moving people to 70E in a more straightforward fashion, right? Compliance with industry recommended standards, which is 70 is the one for North America, I think really sets the stage to make sure that whether you can use a table method using the parameter data that you just mentioned, Kyle, or whether you're actually going to do an incident energy calculation. So either path now, your direction to 70E, and then that'll let the standard where those requirements lie dictate what path you take and what the actual marking looks like. You know, I think that this provides insight on where we came from the 2020 NEC to the 2023. And this is an example where simplification is actually better, right?
Yeah, you know, the evolution here was kind of natural, right? We started with service equipment. The arc flash hazard doesn't just exist at service equipment, so expanding that to feeders as well makes perfect sense. An additional, from a risk management standpoint, it now expanding this as an installation requirement provides, you know, again, it increases worker safety and allows individuals to continue to protect themselves when they're working on these hazardous equipment and situations. Just another example of how 70E and NEC are working together this cycle.
Toby, what are your thoughts here?
I think it's really important to have this labeling, especially with the date and the incident energy. So when you go to work on a system to modify it, maybe you're adding a circuit or something like that, a motor, you could be actually increasing the arc fault hazard at that location. And I think it's going to be good for the AHJs too to say, hey, you need to update your arc flash study as well.
Yeah, Toby, you brought up a great point. The date of the label, and this ties into that requirement for qualified maintenance and service individuals. Somebody that's qualified is going to identify that label is out of date and know that they need to ask some questions before they start performing maintenance on equipment while it's energized.
So let's move on to topic number 3. And this is a topic that could end up resulting in costly changes if not understood properly. So let's talk about the potential impact to the size of the electrical room. Toby, can you explain the changes related in this area and how that impacts you as an electrical contractor in terms of space requirements?
Yeah, 110.26, the working space, is probably, I think, the most important change for us contractors. This section's all about working space and egress. And it's been a concern for a long time how equipment doors should be accounted for our working area and egress. This change states that the equipment doors in the open position have to still leave 24 inches width and 6.5 feet tall clearances for egress.
You know, Toby, a graphic or illustration might help us with this visually. And I think that as we look at the slide on the screen now, We have an example where we're using large equipment because, again, the large equipment would have the largest door sizes that might protrude into the working space. And in this case, if we were to think about this, we know we have a requirement that doors must open a minimum of 90 degrees, but in often cases, equipment doors will open further than that. So sometimes there's a little calculation that you have to do to figure out how much does it protrude into the working space. In this example, if we were to take a 480 volt switchboard, and if we would say at the edge of the working space we have a grounded concrete wall, then this would be a condition 2 condition for the table 110.26 and would require 3.5 feet or 42 inches of working space clearance. And if we would take a standard switchboard door that's 30 inches wide and opens 120 degrees, now we calculate we're protruding into that working space 26 inches, right? So we no longer, with 16 inches remaining, we no longer have that 24-inch egress entrance path that you just mentioned, Toby. And so the electrical room has to get bigger to accommodate that. So I think that's a big issue to consider.
Yeah, electrical room is my biggest concern. With multiple equipment lineups, we can have pieces of equipment that face each other, and those opening doors could intrude into each other.
Oh, that's a great point. When we think about multiple equipment lineups, there are so many additional configurations to take a look at. We have a graphic for that as well. And if we look in this graphic illustration where we do have facing lineups, you have to consider open doors in both lineups. And do you still maintain the 24 inches egress entrance path that's required? So I think when you look at in both cases, it's really important. When we think about an e-house or other areas like that, you may be really in a constrained location, and it's important to make sure you have that egress path.
Yeah, and it's important to remember too that the measurement for that egress path is taken with the doors open at that minimum 90-degree angle. The code requires that doors are open at least at the 90 degrees, so that's how we measure our egress path. Now, even if the equipment is capable of opening the door more than 90 degrees, you know, that's all well and good if there's no constraints and limitations about the space specifically where that equipment's being installed. So even though you may have the specifications from the manufacturer and know that that door is going to open more, now you get onto the site and there's actual physical constraints of that electrical equipment room that won't allow for that door to open more than 90 degrees, you're back at square one, and you have to take that into account as well. So a lot of pre-planning that's going to be needed for these types of installations and to comply with this one.
Yeah, contractors really need to review the plans and the equipment early on in the project because this could change the floor plan of an electrical room. We also need to be aware that not only are our building inspectors going to be checking this, but the fire marshal as well when he comes to check for egress and stuff like that. And then we have addition of PV, energy storage equipment. We start putting those in electrical rooms. Now are we encroaching in the existing switch gear? It's just a lot of things to be concerned about as far as clearances and egress. Absolutely.
And even in addition to the requirements now for accounting for the doors as part of your egress path, we saw some other changes in 110.26, specifically the addition of a requirement where we have to start considering the graded area for that entire working clearance space. So the width and the depth of that workspace, the ground, the area in front of that equipment has to be smooth, graded, level, to ensure that the worker that's performing that service maintenance or needs to examine that equipment while it's energized has a nice flat level area to work in. This can become specifically difficult if you're in an area where the electrical equipment is outside and you require that working clearance and you're up against maybe a property line where you don't necessarily have control over the entire working clearance because it extends into an adjoining property. So it's some things that we need to be aware of during the planning stages as well.
Yeah, a big concern of mine because I'm in California and all our switch gear's outside because we got great weather.
Yeah, you can think of in some areas though where the land really rolls though, it can be a worker safety issue to make sure that you have the space or someone can work safely.
Absolutely.
So it feels like there's been subtle changes to these codes year over year with each code changes in terms of the space requirements. Contractors need to have a good understanding so they can help educate not only their employees, but as well as their customers and those that are going to be doing servicing on the equipment. So this moves us into topic number 4 today. And for the past few editions of the NEC code, we have heard about new requirements, adding line side barriers with new service equipment. Chad, I want to go to you again here, and I want you to explain for our audience how the NEC change for certain feeder installations have been impacted.
Yeah, thanks, Kelly. So in 215.15, we have a new requirement for feeder barriers. Now, this is very specific, so we probably have to get a little bit into the technical details here because it has to do with feeder tap conductors, or equipment rather that is fed from feeder tap conductors or transformer secondary tap conductors. And again, I think as Kelly mentioned, we would agree that there are installations where this is difficult to turn off the main feeder. So you've tapped a main feeder or you've tapped the secondary of a transformer to supply equipment, and those are some cases where maybe an energized work situation might actually come into play. And so these line side barriers, they provide protection against inadvertent contact with uninsulated energized live bus and those terminations. So if we think about this equipment, the disconnect in this equipment, we're talking about the line side of that disconnect. I know a lot of times we think about the service when we talk about line side, but this is actually a feeder. And I think that it's really important in the specific equipment. We have switchboards, switchgear, motor control centers, and panel boards specifically mentioned here as requirements to make sure that when that disconnect for those products is in the open position, you have some type of inadvertent contact protection. So Toby, talk to us about how this mirrors what's in 230.62C for services.
Yeah, I think if we look at 230.62C, it really helps clear this up. And if we look at the history of 230.62, we see in 2017 NEC, they added panel boards, and in 2020, they included all service entrance rated equipment.
Yeah, and these feeder taps, Chad, that you're describing, transformer secondary conductors that terminate in these panel boards, switchgear, switchboards, or motor control centers, they pose the same hazard that Toby was talking about in service equipment. They're infeasible to de-energize, which is one of the justifications for energized work in NFPA 70E, and providing that insulation barrier, it goes a long way in preventing what we would call like a human error mistake that causes an arc flash incident. You think back to when you worked in the field, how many times did you drop a screwdriver in a piece of equipment? And now having these insulated barriers in place will help protect from an arc flash occurrence happening. It's also important to remember that these barriers are not in lieu of any type of hazard or risk assessment, that there's still PPE that's going to be required as well.
Yeah, that's a great point, Kyle, because we have 3 main electrical hazards, right? Electric shock, arc flash, arc blast, and this really addresses enhanced protection for electric shock, yeah, right? It does do some risk abatement for potential arc flash. But when we think about this barrier, and particularly in large equipment such as switchboards and switchgear, it only comes into play in those sections of equipment where you have load terminations. So if we think about large equipment such as switchboards or switchgear or other custom configurations where maybe you have bust into that disconnect and bust out and there's no load terminations in those sections, I just want to make sure everyone's aware that, that you wouldn't have barriers in that equipment, right? And as Toby mentioned, for a really long time, we had a requirement in Article 408 for switchboards and switchgear. And then 2017, we expanded it a little bit, and then 2020, we opened up to all service equipment. But the large equipment sometimes accomplishes this inadvertent contact by distance. In other words, distance within the enclosure, because these are really large pieces of equipment. And where those load terminations are, it may not be reasonably probable that you could have inadvertent contact. Obviously, if you're doing other type of work, then you need to have the proper workplace permissions to do that. So I think that there's a tie here between all of these and how that fits together, and I think your point's well said about how this enhances worker safety.
Yeah, and just to reiterate, it's important to understand that these barriers are not necessarily the end-all be-all from a risk management standpoint or a risk assessment standpoint. Still need to consult NFPA 70E and make sure that we're assessing the hazards and donning the PPE when necessary.
Yeah, as contractors, we need to understand the limitations of this protection, right? It's mainly a shock protection. We still have our other 2 major hazards is arc flash and arc blast.
Let's move our focus now to the new energy landscape area where there has been so much technology advancements over the past several years. A key area of industry confusion is around the rules on the line side, right? And particularly in connections to solar, wind, and other DER resources. So, Chad, I would like for you to walk us through what has been addressed with these new code changes.
Well, thank you. So 705.11 went under significant revision in the 2023 NEC. When we look back in the 2020, there was a long list of set of questions there, or requirements there, and a lot of pointers back to Article 230. So what I will say is that this code change moves 705.11 really in line and essentially points back to say that these connections are treated like service conductors, service connections, and would follow those service connection rules.
Yeah, like you said, industry confusion is what drove a lot of these requirement changes and changes in Article 705. By including and mentioning these sections in Article 705, specifically the parts of 230 and 250 applying to the service requirements that apply, the grounding and bonding requirements that apply, and the grounding electrode system requirements that apply, it makes it much clearer for the installer and contractors doing those installations.
So the requirements in the existing Article 230 really are already addressed, the three major ways these connections are made. 230.2 included a new service just for this connection of these renewable sources or on-site generation sources. 230.82(6) included the connection ahead of the service disconnect, which is what we most often see. And then 230.40 exception number 5 included that additional set of service conductors. So when we look at this in total, really the requirements were already there, and anything we put in 705.11 were really going to be redundant. And so I think that importance, that change really clears up the requirements. Kyle, you mentioned grounding and bonding. It also answers the question, are these service conductors? Is that system disconnect a service disconnect? Now we have really clear requirements for all of this new on-site connections.
Yeah, I'm really happy with this change. It cleared a lot of misinformation up and also got rid of the conductor length restrictions, which now allows us to follow the same rules as service entrance conductors, which is really good for those situations where we have unique buildings or equipment locations, and then going back to working clearances, maybe we got to move that disconnect away to make sure we have our egress and clearances. But it's still good to talk to the AHJ to ensure agreement on installation, and we also have to remember that we still need to be at 230 and basing a minimum size conductors, number 6 copper, number 4 aluminum.
Mm-hmm. Yeah, this could be a completely different perspective for some contractors that maybe don't do a lot of this type of work, and it could cause big problems if and when they don't have people with the basic understandings of these types of electrical installations, specifically around solar and battery energy storage systems.
Yeah, that's a good point. And 705.11(c)(2) states that any modification must be field evaluated and per the manufacturer's instructions. So we got to be aware that we can't just throw piercing lugs and hook up to the service entrance conductors and tap off of that. We might have conductor fill issues or bend radius problems.
Yeah, I think there's nothing more frustrating, right, than the fact that if you try to make one of these connections or you're inspecting one and you didn't have the wire bending space, the equipment wasn't really designed for it. And so we have to remember we got 3 other choices. We have 3 total choices. So if you can't do it within the service equipment, then maybe one of the other methods work.
So I want to take since we have a little bit of time left today, I want to take the panel in a slightly different direction. Today, 65% of end users have KPIs around their energy management. So I want to ask you all to kind of talk about the new energy landscape and how these code changes are going to help end users with achieving their KPIs around return on investment of their energy distribution services.
Well, I think there is a big change in the 2023 NEC around energy management systems. And I think that's probably shows the most impact, right? We're used to energy management systems used for compliance with the energy code, but we have now allowances where we can actually size the electrical infrastructure based on the use of an energy management system. I know, Toby, in some of the renewable spaces, you're using energy management to manage load to source.
Yeah, especially with our utility, we have peak time, so it's nice to be able to run off your battery energy storage stuff during those high peak times to keep operating costs down.
Yeah, you know, the way we use electricity is changing. The need for using electricity in situations where we might necessarily, especially in dwelling industry or dwelling units and residential buildings, is not necessarily going to be the same anymore. So the code has to evolve to make sure that they're ensuring and keeping up with these new technologies. So there is regulation on how these get installed. If there's no code or regulation and it doesn't keep up, then you end up with some serious issues out there with some of the way some of this stuff gets installed.
Yeah, and I think when you think about backup power systems, whether it's the home, or it's the commercial building, or it's a critical function like healthcare or emergency systems, these new sources, they continuously operate. We're used to those traditional sources that just sort of sit by in a standby mode, and they don't start until they're called on to run. Energy storage, photovoltaics, wind, these systems, fuel cells, they need to run continuously. So all of those abilities to have energy management and supply normal loads or building loads and then provide backup power when they need to.
Yeah, and I think it's important to talk about being in this industry, if you are in the renewables and the energy storage, to make sure you are sending out to NFPA about code changes and recommendations that you're seeing in the industry, the new technology that's coming up.
Yeah, I think that's a great point, Toby. If you get behind on code and code education, you can be pretty far in the dark about what the requirements should be for a safe installation. Yeah.
You know, it's also kind of altered the way we look at the ability to support emergency and legally required standby systems in these facilities as well. You know, for a long time, it's always just been you need emergency system backup or legally required system backup, you installed a generator. Now new requirements in the NEC or new permissive requirements in the NEC allow to use energy storage systems for those systems in addition or in supplementing backup generator.
Yeah, and that alleviates a lot of concern, right? It uses the clean source first and you know, can reduce how much like diesel fuel you have to store on site, which is also a concern for aging and keeping that fuel and system ready to run. So there's lots of benefits here in the way that works, and I think it's a pretty exciting time, this new energy landscape.
Given that 30% of construction costs come from change orders, I think an important topic that we need to discuss today is selective coordination. As from my experience, it's one that's often missed. So Kyle, what are your thoughts on this topic?
Yeah, this selective coordination is one of those issues that always crops up right at the end of a project and usually isn't thought of until certificate of occupancy or they're trying to complete that installation. The revision that was made for the 2023 NEC specifically applies to selective coordination and emergency system settings. Not only applies to the emergency side of the overcurrent devices that supply that, but on the normal side as well. Basically everything upstream, normal and emergency side for that emergency load has to be selectively coordinated. And it's one of those things that, again, nobody thinks about it till the end. And now you're trying to race around and make sure everything works, and a lot of times it doesn't. It's also ties into our discussions about maintenance and qualified workers. When you're maintaining electrical systems and performing routine service and maintenance, and you have to replace an overcurrent device, if you don't do that with a like device, now you've just altered that selective coordination study, and that system might not be as reliable as it's required to be. So that's where the qualified worker part comes in, and make sure that they understand the impact that they're having on that service and maintenance and that equipment.
Yeah, that's a good point, because a service electrician might be replacing a breaker. He replaces it amperage for amperage, voltage for voltage, but doesn't realize that the arc fault rating could be different.
Yeah, the trip characteristics play a big role in that, for sure.
You know, in every code cycle, there's what I call a big sleeper change, the one that didn't get a lot of discussion, and I think this is one. And I think, Kyle, you mentioned this, but I think it's really important. This being located in 240.11, it's the trigger is in other parts of the code. Like we have requirements for selective coordination for elevators. You mentioned emergency systems. So spread across the code, we have these triggers for selective coordination. And now back over in 240.11, once that trigger is in place, now you've got additional requirements on the normal side. It's pretty easy to miss, Toby.
We've covered 5 fantastic topics here today. I know I've learned a lot from all of you, and I want to thank you guys for spending your time with us here today. Before we close, are there any final comments from from our panelists?
Well, I think you agree. We hit 5 big topics. Obviously, there's others out there, and I think being educated on the code is a really important thing for folks to invest their time in.
Absolutely.
Definitely, and I'd like to thank Chad and Kelly and Schneider Electric for allowing me to be here and participate. And also on behalf of NECA, thank you to Schneider Electric for being a premier partner.
Yeah, as a contractor, NECA is a great resource for education, updates, and just overall improvements as being a contractor. I think they're a great resource.
Fantastic. So thank you all for joining us today. If you would like to learn more about these 2023 NEC code changes, please visit our code and standard pages on se.com.